Alrighty, everyone. Good evening and welcome to tonight's Weather Chat with Timmy. I am, Timmy Albertson. And hey, take a look, folks. We got ourselves a brand new little intro here that accompany our Weather Chats here. So there it is with yours truly. Alrighty, everyone. Well, with that in mind, of course, it's been a while since I've done a Weather Chat where I was kind of getting some new technical things set up here. As you can see, picture quality a little bit better. That's pretty good, isn't it? And not only that, folks, but to accompany my little return from my brief week hiatus, there's nothing active weather-wise going on. Yeah, so it's actually very quiet out there, and unfortunately, it's likely going to be staying that way as we go through the next couple of days. So let's go ahead and flip on over here, folks, to the latest weather map, and we'll take a look here, kind of what's going on. So for those of you around the New England area, okay, you had a little bit of active weather, let's put it for you that way there. It hasn't necessarily been the quietest for you guys. Had some snow there during the overnight hours, even a little bit in the way of some freezing rain. Not the most organized, not the strongest system that New England has ever seen, but at least a little quick taste there of winter. Unfortunately, much like with New England, pretty much everyone else is that it's going to be getting a little bit quiet out there. And part of the reason for that is going to be courtesy of an area of high pressure. Now, if we zoom out here a little bit on the weather map, we don't necessarily see a particular center here of high pressure, but what we do see is this kind of long frontal boundary that snakes its way all the way down across Texas and into parts of the desert Southwest. And if you look a little more carefully, you can see that area of high pressure right there. Again, not the strongest area of high pressure, but enough that it is keeping things pretty quiet. As a matter of fact, it's going to kind of keep things, at least weather-wise, generally quiet across a good half of the eastern United States over the next few days. However, it's not necessarily going to keep the weather quiet everywhere, because if you happen to live in the deep south, well, it could end up being maybe kind of a rainy and stormy next couple of days. So let's go ahead and do something just because it's pretty quiet out there. Let's go ahead and take a look at one of the models here. And again, folks, I show you these models not to be taken literally, just to kind of help illustrate a little bit of what we're talking about here. So this is somewhat of a short-range model here, and I know you see a lot of things here on your screen, so we'll go ahead and kind of zoom it in a little bit here. This is the main one that you want to focus on. I'll even kind of scoot it over there a little bit so I'm not blocking it. So with this particular model here, what we're seeing is more or less kind of a short-range ensemble model. But basically, more or less, you can kind of see our area of high pressure. Now, again, it's still trying to build its way across the central part of the U.S., but you can see as we move through the next couple of days, that area of high pressure kind of gradually tracks its way towards the east and really just kind of takes over a good chunk of the Great Lakes area, keeping things very quiet there. Now, there's a lot that can actually be deciphered here from this particular model run, and we're going to come back to that here in just a quick moment. But what I do want to focus you on here, at least quickly here, is take a look down across the deep south. We're pretty much right along the Gulf Coast there. And this is an area of high pressure, naturally, and it's trying to, bring its own air mass in, somewhat kind of cooler air, but not necessarily the coolest there. But it is producing enough forcing, so to speak, that we are seeing some showers and probably even some thunderstorms that will be developing across parts of the deep south as we go our way into the weekend. Just that area of high pressure kind of forcing that moisture to have nowhere to really go. And I'll save you all the meteorological lingo for that. But you could just kind of see probably some rounds here and there of some scattered showers and thunderstorms as that area of high pressure just sits over the eastern part of the U.S. Again, that moisture trying to come up from the Gulf doesn't really have anywhere to go, so it's just kind of forced there. And again, nothing unusual for that area there. But so there will at least be some weather going on over the next couple of days, so that will at least help to give us something to talk about a little bit there. But right now, not looking like that's really going to be not expecting it to be an organized severe weather event or any, along those lines there. Probably just some general scattered showers and thunderstorms. So again, that's just kind of the case there. So we can even see that right now if we were to actually flip over to the latest radar imagery, and don't worry, we're going to come back to this map here in a moment because there's a couple other things I want to point out. But if we flip on over to the Shreveport radar here, you can see that they are seeing some showers and probably even some embedded thunderstorms, at least at the time of this recording. And again, this is probably going to be somewhat of the scene across a good part of the Deep South, maybe over the next couple of days. Just some of these showers and some of these thunderstorms just moseying their way around, courtesy of that high pressure that is, really just going to take control over the Great Lakes region. So let's go ahead and go back to this map here, because I do want to talk about this area of high pressure a little bit. And, I did say that things are going to be pretty quiet, but even in weather, when things are quiet, they're not necessarily quiet, if that makes any sense. So let's take a look here at this particular model run here. Again, this is looking towards Saturday morning. All right, now, again, folks, it could end up maybe shaping up to be a little bit different than what you see there, but this will at least kind of help to give us a good illustration of what will be going on. All right, let's talk about that center of high pressure there. All right, we got this guy, centered across, the Great Lakes region. And we've talked about it before, and I've mentioned it numerous times before, but, the way things work in the northern hemisphere, well, actually, the way things work in general is that high pressures kind of are the dominant one. And with the pressure gradient force, what you see a lot of is, of course, air flowing from an area of high pressure to an area of low pressure. Now, there's some other factors that eventually kind of cause it to veer its direction a little bit, one of them being obviously the Coriolis effect. But long story short, what this translates to in, the northern hemisphere, at least, is a clockwise flow around an area of high pressure. So we're talking about the surface here. We're going to kind of ignore the upper levels here, and we're just going to kind of generally talk about the surface here. So the lower levels of the atmosphere, that's what this map here is for, pretty much surface. So we got this area of high pressure right there. And basically what's happening here is we got the air that is more or less kind of going in a, clockwise direction around this area of high pressure, moving away, air, moving its way away, but getting deflected. And a long story short, turns into this clockwise flow here. So when we get an area of high pressure like this, that makes its way into, in this case, the Great Lakes area, we can already start to see a little bit here of the wind directions. Let's put it for you that way. Winds across New England as we go into early Saturday will probably be coming their way out of the north, give or take a few degrees, coming their way out of the east across the Deep South there, and then trying to actually become a little bit southwesterly up here across the upper part of the plains. And when we start seeing these pressure lines really close together here, that's a good that's a very tight pressure gradient, which means the winds are probably going to be, a little bit on the breezy side, especially kind of right around this area. It'll be probably a little bit on the breezy side in the Deep South, but again, not a very strong wind. But take a look at this up here. And that's actually an area of low pressure that's going to be making its way into the Western Canadian coastline there. And with our area of high pressure there, it does help to create a little bit of a pressure gradient, as well as a kind of another area of high pressure over the Rocky Mountains. And take a look at how tight these are. These are some very tight pressure gradients there. And what's interesting about this is that I do believe they actually do have some high wind watches already in effect for parts of northern Montana. So that'll give us something to take a look at. There are some very breezy conditions across Montana. But what this also tells us here is that this area here of the high pressure, okay, is going to be bringing in some warmer air. And eventually we see here as we go through the weekend, that high pressure begins to track its way a little bit over towards the east. We can also see here that we have this pretty decent southwesterly flow going into parts of the upper Midwest by the time we head into the day on Sunday. Now, if we're to flip over to the upper levels here, and again, so we're going to kind of switch gears. We're just looking at the surface. Now we're going to move into the upper levels, and I want to show you something else that's going on here. And in meteorology, this sometimes makes for not only tricky forecasting, but can also make for things to be a little bit on the boring side. So let's take a look here at the upper levels. And folks, I know we've talked about this before. If you haven't, if you weren't there the one time a few weeks ago where we talked about the upper levels, don't worry, we're going to come back to it more, especially when we start getting some pretty strong systems here. But what I mainly want to show you here with this is we talk about troughs and ridges in the upper levels here. But what happens when you don't really have either of them? Well, we call that a zonal flow. All right. And that's kind of what we have setting up a little bit as we go towards the end of the weekend across, the central and western half of the country. Notice how there really isn't a defined. There is a little shortwave, well, I don't want to say little, but there is, a decent shortwave trough over here and a little bit of ridging over here. But all things considered, there really isn't a predominant, large scale, upper level trough or upper level ridge. And so we kind of call this in meteorology a zonal flow. And this is basically, unscientific explanation for it is that it's kind of a equilibrium, I guess you could say. Things seem to be a little bit content. Normally in weather, everything happens because it's trying to even everything out. But when we kind of see this, it sometimes is a good indication that there really isn't a whole lot of exchange going on there, and to a degree, it can make forecasting a little bit on the boring side because generally that's kind of accompanied with quiet weather. However, we also have a saying in meteorology, zonal flow forecasters woe, because you get a little disturbance like that or this little guy up here that kind of races its way through, well, that can produce showers and thunderstorms there. And eventually, this will probably evolve into, a little bit more of a defined upper level system. But unfortunately, what it's looking like it will evolve into is somewhat of some upper level ridging across parts of the United States. So, zonal flows, not unusual, especially in the summertime. We kind of tend to see that quite a bit there. And, this is, there's a lot more going on than just that. So I don't want to give you the impression that every time you would see that on an upper level chart, it means things are going to be quiet, because sometimes that's just not the case. And what separates this from, you might be looking at this and saying, what's the difference between this and, trough? Well, keep in mind, folks, the way the Earth works, warmer around the equator, colder at top, right? Warmer around the equator, colder at top, generally speaking. When we see these lines here, more or less kind of going west to east, you get the idea that, the temperature is to a degree, again, we're glancing over folks here, somewhat uniform, kind of what we'd expect to see. Warmer down south, cooler up towards the north. So again, the upper levels kind of will hint at that a little bit. Now, again, folks, this is not the best example of a zonal flow, but it does kind of help to illustrate that things might be a little bit quiet over the next few days. But even within those zonal flows, like I said, we get a good little disturbance that kind of rides along it. There'll be some shower and thunderstorm activity or snow, whatever the situation with the temperatures is. So again, like I said, it can make for kind of a mundane forecast, but it could also be a very tricky forecast too. And so that's probably going to be the case in some parts of the northern part of the U.S. is that, again, say for, that little, what seems to be here, that little disturbance there riding its way through as we go into the weekend, but all things considered. And then eventually this will probably form into a little bit of a ridge there. And so we probably are going to be seeing above average temperatures, especially across the upper Midwest, as we go into the start of next week. Unfortunately, things get a little bit muddled beyond that. So what about long term here? Well, Thanksgiving is coming up, and it looks like around that time, well, maybe a little bit before that, we could see things getting a little bit more active. Now, folks, you got to understand in forecasting that, there's a lot of models and stuff, but there's still limitations. And the way that models work, and one of these days we'll talk about models more in depth here, so you kind of get a little bit of an understanding here as to how these things work. And again, they're just computing equations. Basically, you're looking at a giant calculator. There are some differences. Part of that has to do with initialization, and also sometimes the equations that are being used, if there's rounding and whatnot. So it can kind of offset itself, and eventually it could spiral into some of the wacky solutions. In fact, there was one from the GFS that I was just looking at, which, if it came true, would be pretty interesting. But I don't think it will, because it seems to be a little bit extreme. Case in point here, folks. Let me go ahead and pull it up here. We're going to flip back over to the full screen here really quickly, but I'm going to pull up to you what I saw from the GFS earlier on today. Now, again, folks, I don't normally like to show model data when I just in general, outside of, general forecasting, because, people look at computer models and then they instantly assume that that's what the weather's going to be. One of the things in meteorology, that you got to learn is when a solution may not be very good. Now, again, keep in mind, folks, in weather, all things are possible. All right. So there's not necessarily such thing as a bad model run, okay? Because in theory it could happen. However, when it comes down to practicality and likelihood, there are some that are just a little bit out there, and none more so than the latest run of the GFS. And again, I don't like to normally show modeled stuff, but it's pretty good actually. So I'll just show you kind of the simplified version. I believe you can actually pull this up from Tropical Tidbits. When I do forecasting, most meteorologists kind of have their own thing. So the GFS model that I look at is a bit more detailed and stuff than what you see here, but I just figured this one is going to be pretty simplified for you guys. So let's go ahead and take a look at this bad boy here. So just watch. Here I am laughing at it. Who knows? It might end up happening. That would be something, though. So let's go ahead here and zoom in here a little bit. And I want you to focus down here across parts of the Caribbean. So let me go ahead and see here, actually zoom out here really quickly and just see if I can scroll this down a little bit so that you guys can get kind of a clear view of it. I promise this is worth your time because like I said, it is actually pretty good here as to kind of what it's showing a little bit here. So we'll zoom it down here just a smidge so that we can make sure we get the Caribbean in it. All right. So this is an installation so far. Looks to be pretty reasonable. It picks up on this kind of area of disturbance down in the tropics, okay? Down here around Honduras and Nicaragua. It takes it, all right? And basically over the next few days, effectively evolves it into a tropical system, judging by the obvious pressures and everything else that's going on. What's interesting about this is that normally when we talk about hurricanes, especially at this latitude, they generally go east to west. Not always. There have been exceptions, but those are not very normal. So already this is kind of screaming to be a weird setup because it's showing us a pretty defined tropical system that's going opposite where we would normally expect to see those systems moving. Like, again, it's happened before, though. But take a look at this thing. So this thing effectively intensifies. It runs over Cuba, okay? And right over Guantanamo. And glances by Hispaniola, all right? So now we're talking about a pretty decent-sized hurricane here. Probably Category 3, probably at least by this point. If I got my pressures right in my head, that would probably be a Category 3 hurricane. And then it emerges over the Turks and Caicos. And look at this thing. It's going straight to the east. Again, not, it's not that it's never happened, but again, for reasons we won't get into tonight, not necessarily a very common occurrence. And I'd have to look back to see in the records if we've ever had one that strong at that latitude that is tracked that way. But that's besides the point, okay? Let's keep advancing this thing. This thing blows up into a really big hurricane, and then it just stalls out north of Puerto Rico, all right? All right. It gets weirder. All right. Meanwhile, we got our high pressure that's sitting over the eastern part of the United States. And let me double check here at what part, where exactly we are here day-wise. Because this is, now folks, also keep in mind here that this particular model tends to, this is a long range here of the GFS model here. So I just want to zoom out here. Yeah, and we're already looking towards the day before Thanksgiving. Okay, so we're looking about 330 hours out. For most models, 168 is considered long-term. That's a week. But in reality, 96 hours, I think is, well, I would argue that, beyond 72, it starts getting a little dicey with some of the. Anyways, let's continue on with this thing. So, as we go to Thanksgiving, we got ourselves our good friends here, this hurricane that's now tracking its way in a slightly more normal direction up towards the north. Then we got this giant low pressure developing off the east part of Colorado. That's not unusual. All right. It then shoots its way up towards about the Fargo area and continues to intensify. Meanwhile, let's focus in on our hurricane friend. It begins to interact with a low pressure up around Quebec. And let's go ahead and see if I can't inch this thing back up towards the north because it gets pretty good here. I'll zoom it out here just a little bit. And let's see here. There we go. That thing becomes extratropical and explodes to a pressure of about 921 millibars. Folks, that would probably be the equivalent of a good sized category 4 hurricane, but for that being an extratropical system, which is not a hurricane, that's an insanely low pressure. Okay? And it just looks like it beats the heck out of the North Atlantic there as a massive extratropical cyclone that just, that. So, yeah, that was the latest run, folks, of the GFS. So that's why you need to understand, folks, when you're looking at models, things, there's going to be weird runs here. And in fact, and I'll show you what I mean here. Let's back it up to an earlier run, just a few hours earlier. And you can see here how it shows that same massive system as a little bit more normal of an area of low pressure, something a little bit more believable than an extratropical low of 921 millibars. Boy, would that certainly be interesting, though. But so again, you get the idea. But I just figured I would show you that. Again, you can see it here kind of spinning its way. It does kind of hint that. Okay, so it does hint. Whoa, hey, let's back that up here a second here. I just flipped up. So it does show, however, a little bit of organization down in the tropics, but not much. And you can see how it just gets absorbed. And again, we've talked about most hurricanes meet their end in one of two ways: they hit land or they run into a cold front. And so in that case, you could see how looks like it's implying that a cold front would be here. And folks, this is so far out that we're looking at next. Oh God, we're looking at what, 10 days away. So I mean, at this point, it's negligible. This is not anything that you would want. If you do long term forecasts, yeah. But that's not the point. The point is that this far out in the model, it just kind of sometimes becomes comical. But again, so in that particular one, it does show a little bit more believable of a scenario of something coming up, some type of tropical system. And then it gets caught up in this cold front with this, stronger area of low pressure moving out of the Great Lakes. And you can see how it just kind of gets absorbed in there and then eventually just does its thing and tapers away and new areas of low. So that's a little bit more believable. But again, folks, when you're going that far out, anything's believable there. So I just wanted to point that out. And some of the other models don't show this really going on. But I just figured it was something entertaining. Because, I mean, let's see here. That's what I should have done before we did this weather chat tonight, was I should have gone in and seen what it's implying for some of the numbers, because that's crazy. I mean, it kind of looks like a yin yang too, with the upper level height lines. You got it, that, there you go. It kind of looks like a yin yang. Boy, that is insane. So basically, if you're a boat within 300 miles of that, you're probably gonna sink. That would be kind of first guess there. So again, you get some pretty good ones. I don't want anyone thinking here that I'm saying this is going to happen. Okay, I of course, but then again, we're looking so far out. As mentioned, anything's possible. But this would be what in meteorology you might consider a bad model run, at least in the long term. Short term doesn't look that bad, but long term, Yeah, that's. It's not the weirdest thing I've seen though. There have been weirder. But that is not that's something I'm going to look into. And you know what? Remind me when we do tomorrow's weather chat. I'm going to look. I'm just going to look to see if there's ever really been. Uh, I mean, that would have to be that would have to be a record setter in terms of extra tropical low because there's no way at this point that it's yeah, there's no way at this point that it's tropical. And the fact that it blows up even more so once it becomes non-tropical, because you could see, colder air aloft and everything, this thing transitions from more of a warm core system to a typical cold core low at this point here. That would be awesome, though. I mean, that would be something. Uh, yeah. I mean, it's got that pretty decent high over Greenland, but yeah, that is uh, that is impressive. So, with that in mind, folks, now you got a little bit of what we meteorologists have to deal with sometimes. Uh, that's just awesome. All right, I have a monitor here in case some of you guys ever wonder why I'm looking over here. I literally have what you see there on the screen on a monitor up here. Uh, yeah, that's just the way it's set up here. So I got two screens here. So the screen and then this screen over here. So I have two monitors, and so that's what I'm looking at a big picture here, and I keep pointing to it as if you guys can see what I'm pointing to. That's why I got to remember to use the cursor. One of the, for severe weather, we'll probably set it up, where you can see me actually, with this monitor here. But yeah, that's unique. All right, folks. So with that in mind, everyone, that is a look there at the latest in the weather. Tomorrow, we're going to be talking about the Edmund Fitzgerald. For those of you who are not familiar with the Edmund Fitzgerald, it is something that a lot of people on the Great Lakes, especially around Lake Superior and Lake Erie, have heard about. Now, I know there's three other Great Lakes, but because this particular ship uh, frequented Lake Erie quite a bit, and that's where it was heading when it met its ultimate, demise in Lake Superior. For those of you who don't know, Lake Superior has had a lot of shipwrecks. I think these are just some of them. All right, that's a lot of shipwrecks. Okay, Lake Erie's kind of similar because it's shallow. In Lake Superior's case, it's because it's kind of the size of a small sea. Actually, you could kind of argue it is a freshwater sea. But with the strong lows that come in the fall and the wintertime, and even in the early spring, creates very interesting weather up here. And the Edmund Fitzgerald was one of those boats that was a big freighter out in the Atlantic, over in Lake Superior. It was leaving Wisconsin en route to Sandusky, Ohio, and it sank in a very, very strong November storm. That made its way over Lake Superior. So we're going to take a look at that. So make sure you tune in tomorrow. We'll kind of do it like what we did with the perfect storm. We'll take a look at the surface charts, kind of walk you through what some of the weather conditions were for the Edmund Fitzgerald. We do know where the Edmund Fitzgerald is. At the but so kind of have over the past what has been now almost 50 years. Oh man. 50 years, kind of have a good idea of how that ship likely sank. It was just a very interesting one, especially, and just given the weather circumstances. So we'll talk about the Edmund Fitzgerald tomorrow for our weather chat, since there's probably nothing else that's really going to be going on anyway. So it kind of just works out that way. Hey, hey. All right, so make sure you tune in, guys, tomorrow evening. We'll talk about that and everything else. So I hope you all have a good rest of your Thursday evening. God, I almost forgot what day it was. And we'll see you guys back here tomorrow evening. We'll talk about the Edmund Fitzgerald. And yeah, hope you all have a good rest of your evening. Take care. See you back here tomorrow. Keep enjoying that weather.